There is a specific part sitting inside your new heavy-duty truck right now. It costs approximately $50 to manufacture. When it fails, and it will fail, your dealer will hand you a bill between $8,000 and $15,000. And the truck you financed for 84 months, the truck you bought because you needed something that could work for a living, will be sitting on a lift unable to move under its own power. That part is the Bosch CP4.2 high-pressure fuel pump. And it is in millions of trucks on the road right now. But that is just the beginning. Because the CP4 is not a mistake. It is a pattern. And today we are going to walk through that pattern, system by system, dollar by dollar, until you understand exactly why 4 out of 5 new heavy-duty trucks sold in America between 2020 and 2026 are not heavy-duty at all. They are engineered to expire, and the people who built them knew it before the ink dried on your loan papers. Let us start with the business model, because that is where the crime begins. A new heavy-duty truck in 2026 costs between $50,000 and $100,000. Some configurations push past that ceiling. You are financing these machines for 84 months, 7 years. In month 1, the truck loses 25% of its value. By year 5, 65% is gone. By year 10, you are looking at a residual value of roughly 10% of what you paid. But the loan does not move that fast. You are underwater before the first oil change is due, and you will stay underwater for years. The manufacturers know this math better than you do. They have run it. According to their own financial projections, a single owner cycling through new heavy-duty trucks earns the industry approximately $200,000 over a lifetime. That same owner buying one pre-2007 diesel and maintaining it for 300,000 miles is worth $70,000 in today's money. The industry cannot survive on $70,000 customers, so they engineered the truck to make sure you come back. They call this advanced powertrain technology. We call it a planned replacement cycle disguised as innovation. They call it value engineering. What General Motors calls it in their own 2024 quarterly report is a 12% margin strategy built on 70% shared parts between their half-ton and their heavy-duty line. The heavy-duty truck you paid a premium for shares most of its components with a truck that was never designed to work for a living. Stellantis moved Ram production to their Saltillo, Mexico facility, turning out 1,200 units per day. The assembly time on a modern heavy-duty truck is 2 to 3 minutes per unit. 2 to 3 minutes. Your grandfather's shop foreman would have walked off the floor. Ford posted $2 billion in cost savings in 2023 in their own 10Q filing. They did not save that money by using better parts. They saved it by using cheaper ones. And the regulations gave them cover to do it. The EPA Tier 4 mandates that went into effect in 2010 did not just require cleaner exhaust. They required manufacturers to install systems so complex, so failure-prone, and so dependent on dealer-only repair infrastructure that they effectively handed the automakers a recurring revenue model embedded in the drivetrain itself. But the business model is only half the problem. The engineering under the hood has been designed to expire. Let us open it up. Start with the fuel system. Before 2011, Ford diesel trucks used the Bosch CP3 injection pump. Cast iron construction, robust plunger design. Fleet operators documented CP3 pumps running 500,000 miles without failure. The CP3 was not exciting. It was not sophisticated. It worked. Ram would use the CP3 all the way through the 2018 model year. In 2011, Ford switched to the Bosch CP4.2. Ram followed years later, adopting the CP4.2 for the 2019 and 2020 model years before reverting back to the CP3. The CP4 is a high-pressure common rail pump that pressurizes diesel fuel to 30,000 pounds per square inch. It is also a pump with steel-on-steel plungers running on extremely tight tolerances. Tolerances so tight that any contamination in the fuel, any slight variation in lubricity, any microscopic debris causes the plunger to shatter. When the CP4 fails, it does not fail quietly. The steel plunger disintegrates and sends metal shards through the entire high-pressure fuel circuit, through the injectors, through the fuel lines into the tank. The engine dies. The fuel system is destroyed. The repair bill is between $8,000 and $15,000. Aftermarket shops offer a CP3 conversion for approximately $5,000, but that conversion voids your factory warranty. Why did they switch from a pump that lasted 500,000 miles to one that destroys the fuel system at 50,000? The CP4 offered minor efficiency gains that helped compliance with emissions regulations, and it cost the manufacturer approximately $50 less per unit to install. Class action litigation over the CP4 has resulted in a settlement valued at $50 million against General Motors, finalized in 2025 in the Eastern District of Michigan. The allegation was defective design. The settlement included no admission of liability. And for years, the CP4 remained in production. Now look at the emission system behind that fuel pump. Post-2010, every diesel heavy-duty truck sold in America carries a diesel exhaust fluid system. The DEF system injects a urea solution into the exhaust stream to reduce nitrogen oxide emissions under EPA Tier 4 requirements. The system includes a polypropylene plastic tank, a pump, an injector, NOx sensors, and a heating element. Because DEF freezes at 12 degrees Fahrenheit, the failure timeline on DEF systems runs between 50,000 and 120,000 miles, consistently post-warranty. DEF crystallizes in the injector lines. NOx sensors accumulate soot and fail. Cold climate thermal cycling cracks the plastic tank. When the system goes into fault mode, the truck enters what the manufacturers call derate mode, 5 miles per hour, maximum speed, on a highway, in a work truck. The full DEF system replacement costs between $1,500 and $6,000. The parts cost approximately $200 wholesale. Ram issued a recall covering more than 130,000 vehicles for fire risk related to an electrical fault in the intake heater grid relay in 2021. Before 2010, none of this existed. The pre-2007 diesel trucks used mechanical exhaust gas recirculation with steel components. There was no DEF tank to crack, no urea injector to crystallize, no NOx sensor to fail, no derate mode. The truck either ran or it did not, and when it did not, you fixed it with a wrench. They call the DEF system emissions compliance technology. We call it a $1,500 annual tax on working truck owners, collected by the dealer, mandated by the EPA, and budgeted for by the manufacturer before your truck left the assembly line. Now move back to the transmission tunnel. The Ford 10R 140 10-speed automatic transmission and its Ram equivalent handle up to 37,000 pounds of towing capacity on properly equipped configurations. They are rated for heavy-duty work. They are also among the most problematic transmissions ever installed in a working truck. The 6R 140 6-speed transmission that the 10-speed replaced used metal clutch packs and a valve body designed for durability. Fleet operators documented 250,000 miles on 6-speed rebuilds. The 10-speed uses plastic composite clutch components, a valve body with solenoids vulnerable to fluid contamination, and a torque converter clutch that overheats under sustained towing loads. The failure timeline is 4 to 8 years, 80,000 to 120,000 miles. Symptoms are shudder under light throttle, gear hunting between ratios, slipping under load, and the unmistakable smell of burned transmission fluid. Repair cost is between $5,000 and $12,000. The transmission costs the manufacturer approximately $2,000 to produce. A Ford Super Duty drive shaft recall, NHTSA campaign number 22 V087, covered approximately 247,000 trucks across multiple model years. And GM transmission defect litigation is seeking significant damages for multiple model year trucks. The 10-speed was sold to buyers as a fuel economy technology. The transmission hunts between 10 ratios, searching for the optimal gear ratio and reducing engine load. That constant gear cycling is exactly what burns the clutch packs at 80,000 miles. They optimize for the fuel economy sticker on the window. You are paying for it with the transmission. And underneath all of this is the shift in materials across the entire drivetrain. The golden era of heavy-duty truck engineering, 1999 through 2007, used cast iron blocks, steel frames, and hardwired electrical systems with mechanical fallbacks. Ford's current Super Duty uses an aluminum body for weight reduction under CAFE standards. General Motors uses polymer balanced shaft gears, where steel gears ran for the life of the engine in previous generations. Traditional hardwired switches are gone. In their place is a multiplexing computer network, 20 or more ECUs, managing every system in the truck simultaneously. Each ECU is a failure point. Each multiplex circuit is a diagnostic barrier. Each software system is a proprietary lock on your ability to fix your own truck. But the engineering is only half the crime. Wait until you see what happens when you try to fix it yourself. Pull up to an independent diesel shop in 2026 and hand them a modern, heavy-duty truck with a DEF fault code. Here's what they tell you. The diagnostic scan requires either a Ford IDS Pro subscription at $50 per day or a Norwegian Truck Pro system or a dealer-grade tool that most independent shops cannot afford. The fault code may be readable on a standard OBD2 scanner. The reset requires a proprietary flash. That flash is dealer-only. The transmission control module on the 10R140 is software locked. Replacing the valve body without reflashing the TCM produces a truck that will not shift correctly. The reflash is dealer only, $200 per hour on the lift minimum. Replace the NOx sensor yourself with an OEM equivalent part, and the ECU may reject it because the sensor serial number is not registered in the vehicle's software profile. Paired components, serialized parts, the same system that John Deere used to lock farmers out of their own tractors. The fight that went all the way to the federal government is now standard practice in the heavy-duty truck market. Massachusetts passed a digital right to repair law in 2020. The federal equivalent remains stalled as of 2025. In the meantime, NHTSA data shows heavy-duty trucks generating recalls at a rate of 3.2 per 100,000 vehicles compared to 0.7 for light-duty trucks. That is 4.5 times the recall rate. And every one of those recalls runs through the dealer. The depreciation trap closes around you at the same time. That $100,000 truck is worth $35,000 by year 5. You still owe $55,000. You cannot afford to sell it. You cannot afford to fix it at dealer rates. And you cannot fix it yourself because the software will not let you. This is not an accident. This is the business model. So if the dealer is a trap and the new truck is a subscription disguised as a vehicle, does that mean you stop buying trucks? No. It means you stop buying the brochure and start buying the engine. Because there are 3 specific platforms that mechanics have been watching run past 300,000 and 500,000 miles without a major overhaul, and the manufacturers are quietly terrified that you already know their names. The first is the 7.3-liter Powerstroke, the bulletproof 7.3. Ford produced this engine from 1994 through 2003 in the F250 and F350, cast iron block, cast iron heads, hydraulic electronic unit injector fuel system, HEUI, that runs off engine oil pressure rather than the fragile high-pressure common rail design. No CP4, no DEF system, no selective catalytic reduction, no diesel particulate filter. The fuel system is mechanical enough that a competent diesel mechanic can rebuild it with standard tools. Fleet operators and owner-operators have documented 7.3 Powerstroke trucks reaching 500,000 miles on original blocks. The entire injection system can be overhauled for under $2,000 with aftermarket parts that are available at any major auto parts supplier. Target years are 1999 through 2003 for the updated injector design. Budget $15,000 to $35,000 for a clean, well-maintained example in 2026. Inspect the oil fill cap for white sludge indicating coolant intrusion. That is a known weakness on high-mileage examples, fixable for hundreds of dollars, not $12,000. The second platform is the 5.9-liter Cummins, the 12-valve. Ram installed this engine in the 2500 and 3500 from 1989 through 1998, then updated it to the 24-valve version through 2007, cast iron block. The 12-valve used the legendary Bosch P7000 mechanical injection pump. The 24-valve transitioned through the VP44 and then to the Bosch CP3 common rail system from 2003 onward. No DEF, no emissions control beyond a simple EGR valve that can be addressed without consequences to engine reliability. The 12-valve Cummins is arguably the most durable diesel engine ever installed in a production pickup truck. Anecdotal reports from trade publications document examples reaching 1 million miles on original internal components. The 24-valve 23 through 2007 version is the practical sweet spot. Updated injector design, CP3 fuel system, no CP4, available for $15,000 to $35,000 used. When you inspect one, pull the valve cover and look at the rocker arms for scoring. Check the block for the common cracking near the main webbing on high-mileage examples. These are mechanical problems with mechanical solutions, not software faults requiring a dealer subscription. The third platform is the Duramax LB7 and LLY. General Motors introduced the Duramax 6.6-liter V8 in 2001. The LB7, and produced 2001 through 2004, is the purest version. Cast iron block, aluminum heads, common rail injection but with a CP3 pump rather than the CP4 that replaced it. No DEF, no diesel particulate filter in early versions. The LB7's known weakness is injector failure. The original injectors were prone to O-ring degradation and internal cracking. A full set of 8 injectors runs approximately $3,000 and can be replaced by any competent diesel shop. After the injectors are addressed, the LB7 is a 500,000-mile engine. The LLY version from 2004.5 through early 2006 corrected the injector design and added a more robust turbocharger. Budget $15,000 to $30,000 for a clean example. For all 3 platforms, the inspection checklist is the same. Pull the transmission dipstick. If the transmission does not have a dipstick, walk away. Check the frame rails behind the rear axle for rust perforation. This is a structural failure point on high-mileage northern trucks. Check the date codes on the tires. Look at the coolant reservoir for sludge or brown discoloration, indicating combustion gas intrusion. Ask for the maintenance records. If there are none, price the truck accordingly. The only math that matters: a new heavy-duty diesel in 2026 costs $100,000 with 7 years of payments and a projected 10-year total cost of ownership, including repairs, of $120,000. A pre-2007 platform bought clean for $25,000 has a projected 10-year total cost of ownership of $40,000. That is an $80,000 difference. That is the price of mechanical freedom. Here is the verdict. The heavy-duty truck was the most honest machine in American manufacturing. Built for work, built from iron, built to be fixed by the man who owned it. What they are selling you today is not that machine. It is a subscription platform with a truck body bolted to it. It is engineered to fail after the warranty expires, serviced only where they say, repaired only with tools they own for prices they set. Stop financing disposable technology for 7 years. Start buying proven iron for cash. The 12-valve Cummins does not know what derate mode is. The 7.3 Powerstroke has never seen a DEF tank. The LB7 Duramax will outlast 3 generations of 10-speed transmissions. Buy the engine, own the truck, hand the keys to your son, and tell him it will still be running when he is done with it. That is what heavy duty used to mean. Go find one that still does.